Today we move on to yet another simple topic of the lesson, that is light, reflection and refraction. We were discussing the basic terminology related to spherical mirrors. Now today we will discuss an important term, that is principal focus. What we mean by principal focus. Principal focus in the case of concave mirror and in the case of convex mirror we will be discussing in detail. So let's move on to principal focus in the case of concave mirror. In the case of concave mirror. So what the principal focus is? So when a parallel beam of light, what do you mean by parallel beam? All the rays in that beam is parallel to each other. So when a parallel beam of light, when it falls, that means that parallel beam, it is parallel to the principal axis also. So when a parallel beam of light parallel to the principal axis strikes on the concave mirror. So I am drawing all these things, whatever I told now. Okay, we have a concave mirror. Okay, now this is the principal axis. So this point what we call as pole P, and this is the center of curvature. Okay, now a parallel beam of light. You have a parallel beam of light. Okay, so two rays I am drawing here. So this here also normal ray you can draw. Now that ray will be retracing the path. Now here also I am drawing two rays. So all the rays are parallel to each other. So if we have a parallel beam of light parallel to the principal axis. So parallel beam is parallel to the principal axis. So after reflection, all the reflected rays will be converging to a point on the principal axis. So that point we call as principal focus. So after reflection, all the rays will be converging to a point on the principal axis. So all the rays after reflection, they converge to a point on the principal axis. This point we call as focus. So F stands for focus. So how we define principal focus of concave mirror? When a parallel beam of light parallel to the principal axis incident on a concave mirror, after reflection, the reflected rays will be converging to a point on the principal axis. That point is called as principal focus. That point is called as principal focus, and this distance, the distance PF from the pole to the focus, that distance is called focal length. So the distance between the pole and focus is known as focal length. So that is about what principal focus of concave mirror. So drawing ray diagram is very important, showing the focus. Whenever you draw the ray diagram, don't forget to put the arrow mark. Arrow marks are very important. The points P, C and F you have to mark. P stands for pole, F stands for focus, C stands for center of curvature. Now one more point we will discuss here. We say the principal focus of concave mirror is a real focus. The focus is real. What do you mean by focus is real? Actually, the reflected rays are converging. They meet at a point on the principal axis. So since they really meet, that point we call it as a real focus. So focus of a concave mirror is real. Okay, so that is about the focus and focal length of what? Concave mirror. Now we will discuss in the case of a convex mirror. You know the difference between concave mirror and a convex mirror. Now we are going to discuss the principal focus of a convex mirror. So here we have a convex mirror. Same way we have to define, that is, we assume a parallel beam of light which is parallel to the principal axis falling on the convex mirror. So when you draw convex mirror, where will you mark the point C? The center of curvature you will mark here on this side, okay, depending on the curvature. Now you have a parallel beam. You can show a parallel beam of light. This is the parallel beam. Now what we get here is, when a parallel beam of light which is parallel to the principal axis falls on a convex mirror, after reflection the rays appear to diverge from a point on the principal axis. So actually they are not diverging, they appear to diverge. They appear to diverge from a point on the principal axis. So this is how the rays get reflected. Okay, so after reflection, the reflected rays, they appear to diverge from a point on the principal axis. And this point is called principal focus in the case of convex mirror. So in the case of convex mirror, when a parallel beam of light parallel to the principal axis falls on a convex mirror, after reflection, the reflected rays move in such a way that they appear to diverge from a point on the principal axis. They appear to diverge from a point on the principal axis, and that point is called as principal focus. Hope you understood. The rays, actually, you can see here all I used solid lines. Here I used dashed lines. So actually this is how the rays are getting reflected, and the extensions are meeting at a point on the principal axis. So that point where the extensions meet, that's what we called as principal focus. That's what we spoke it physically, that is, the reflected rays, they appear to diverge from a point on the principal axis, and that point is called as principal focus. And here also this distance PF we call as focal length. That distance from the pole is called as focal length. And here the focus is of what nature? Virtual, because actually the reflected rays are not diverging from that point. They appear to diverge. Okay, it's not taking place physically. So we call that focus as virtual. So that is a point to be noted as a point of comparison between the focus of concave mirror and that of convex mirror. In the case of concave mirror, the focus is real, and that of convex mirror, the focus is virtual. Here also that distance PF is called focal length, and you know PC, that distance PC is what? Radius of curvature. The distance PC is radius of curvature. So the thing is this, there is a relation between focal length and radius of curvature. That relation we will discuss now. That relation is, see, R stands for radius of curvature. R stands for radius of curvature, and F, small letter F, stands for focal length. So R stands for radius of curvature, F stands for focal length, and you know R is nothing but PC and F is PF. Okay, so the relation between the two is R is equal to 2F. The relation between radius of curvature and focal length is, whether the mirror is convex or concave, the relation between the two is R is equal to 2F. So only this much for today. What do you mean by principal focus, and what is focal length, and what is the relation between radius of curvature and focal length? Thank you.